Two trains, A and B, are moving along parallel tracks in the same direction. At a certain moment in time, A is located at the point called the origin, and its distance in meters from this point x seconds later is given by the function f of x maps to 3x squared plus 4x. So this function represents the distance from the origin x seconds later. At the instant when A is at the origin, B is somewhere else, and its displacement from the origin x seconds later is given by the function g of x maps to 30x minus 48. So displacement meaning where it's been moved to, meaning the distance and the direction. So part 1, determine the position of B when A is at the origin. Part 2, using the same axes and same scales, draw the graph of y equals f of x and y equals g of x for x values greater or equal to 0, less than or equal to 7. Part 3, use mathematical tools, numeric, graphs and algebra to determine the times at which the two trains are level with each other. And part 4, suggest how drawing a single graph could provide a different method of finding the times at which two trains are level with each other. So it's important to note here that our first function f of x is a quadratic function because we have an x squared, and our second function g of x is a linear function because we just have an x, we don't have an x squared. So part 1, determine the position of B when A is at the origin. So our functions are f of x equals 3x squared plus 4x and g of x equals 30x minus 48. So A is at the origin when x is equal to 0, x being the time. So when the time is 0, 0 seconds, A is at the origin. And the position of B at this time is going to be g of 0, which is going to be 30 times 0 minus 48. And 30 times 0 is 0. So we're left at minus 48. So B starts 48 meters on the negative side of the origin. Part 2. Using the same axes and the same scales, draw the graphs y equals f of x and y equals g of x for x values greater or equal to 0 but less than or equal to 7. Constructing a table of values, including the row f of x minus g of x. So our x values that we're going to input into our functions are 0, 1, 2, 3, 4, 5, 6 and 7. So we want x values greater or equal to 0 but less than or equal to 7. So substituting our x values first of all into our f of x function, which is 3x squared plus 4x, we get corresponding y values of 0, 7, 20, 39, 64, 95, 132 and 175. So we're going to draw the graph of f of x. So we're going to start with 0, 0, which is here. And then we're going to plot the point 1, 7, which is about here. Then we're going to plot the point 220, which is here. Then 339, which is here. Then we're going to plot the point 464, which is here. Then 595, which is here. Then 132, which is here. And then finally 175, which is here. And then we join them together. They form a curve. And this is the graph of f of x. Then we're going to input our x values, which are 0 up as far as 7, into our g of x function, which is 30x minus 48. And we get the corresponding y values: minus 48, minus 18, 12, 42, 72, 102, 132, and 162. Now we're going to plot these points. So we're going to start off with 0 minus 148, which is here. 1 minus 18, which is here. 2, 12, which is here. 3, 42, which is here. 4, 72, which is here. 5, 102, which is here. 6, 132, which is here, which happens to be a point that is also on f of x. And then 7, 162, which is here. And then we join our points together with a ruler because we have formed a straight line because we have a linear equation. So this is the equation, this is the graph of g of x. And then our last row of numbers is going to be the difference between f of x and g of x. So we're going to have 0 minus 48 gives us 0 plus 48, which is 48. 7 minus 18 gives us 7 plus 18, which is 25. 20 minus 12 is 8. 39 minus 42 is minus 3. 64 minus 72 is minus 8. 95 minus 102 is 7, minus 7. 132 minus 132 is 0. And 175 minus 162 is 13. So the graphs y equals f of x and y equals g of x are shown below. Part 3. Use mathematical tools, numeric, graphs and algebra to determine the times at which the two trains are level with each other. The trains are level with each other when their displacements from the origin are equal. So basically, when f of x is equal to g of x. So when they intersect, when they're equal. So numerical, from the last row of the table, f of x minus g of x equals 0, i.e. f of x equals g of x, between 2 and 3 and at 6. So somewhere between 2 and 3 we're going to have 0. So somewhere in between 8 and minus 3, 0 will lie. And definitely at 6 we have 0. So between 2 and 3, the value of x will be nearer to 3, because minus 3 is closer to 0 than 8 is. Hence, our estimate for the value of x is 2.7 and 6. It's definitely 6 because the displacement at 6 is definitely 0, but we only have an estimate of 2.7. Next, using graphs. Well, f of x is equal to g of x, where the two graphs intersect. The x-coordinates of the 2 points where this happens are 2.7 and 6. So this is the point at which the graphs intersect, and we can clearly see it's definitely 6. And this is the other point at which they intersect, and we can see that it's quite close to 3, so we'd say approximately 2.7. And lastly, by algebra. So we're going to let f of x equal to g of x. So f of x is 3x squared plus 4x. And g of x is 30x minus 48. So we let them equal to each other. And we're going to bring everything over to one side. So we're going to bring the 30x over the equal sign. It becomes minus 30x. And minus 30x plus 4x is minus 26x. And then we bring the minus 48 over the equal sign, and it becomes plus 48. So we get 3x squared minus 26x plus 48 is equal to 0. Next we're going to factorise, giving us x minus 6 and 3x minus 8 equal to 0. And then we're going to let what's inside each of the brackets equal to 0 and solve for x. So x minus 6 is equal to 0, so x is equal to 6. And 3x minus 8 is equal to 0. So 3x will be equal to positive 8, and 8 divided by 3 will be equal to x. So x is equal to 8 over 3, which is equal to 2.6 recurring. That little dot there above the 6 means the 6 goes on forever, which would round off to 2.7. So by algebra, we got our accurate answers to be x is equal to 6 and x is equal to 8 over 3. So it would be more accurate to leave it as a fraction, 8 over 3. So we factorised 3x squared minus 26x plus 48 by grouping. So what we did was we brought down the 3x squared and the plus 48. We said 3 by 48 is 144. We got the factors of 144. And we chose a set of factors that together would give us minus 26. So since this is a plus, we knew that the signs had to be the same, and this is a minus, they both had to be minus. So we're going to go with 8 and 18, because minus 8 minus 18 is minus 26. Then we're going to factorise the first two terms, 3x squared minus 8x. So x is our highest common factor. X into 3x squared leaves us with 3x. X into minus 8x leaves us with minus 8. Then we're going to factorise the second two terms, taking out 6 as the highest common factor. 6 into minus 18x leaves us with minus 3x. 6 into 48 leaves us with 8. We notice that what we have inside the brackets on the left is 3x minus 8. And what we have in the brackets on the right is minus 3x plus 8. So we need to change the signs of this expression. So 6 becomes minus 6, minus 3x becomes 3x, and 8 becomes minus 8. Now we have what's inside the brackets matching up. So we have 3x minus 8 as one of our factors, and then x minus 6 as our other factor. So that's how we factorised this quadratic trinomial. Alternatively, since we were trying to solve, we could have used the quadratic formula, also known as the minus b formula. Either way will work out. Part 4. Suggest how drawing a single graph could provide a different method of finding the times at which the two trains are level with each other. To solve f of x is equal to g of x, we want to find the values of x for which 3x squared plus 4x is equal to 30x minus 48, i.e. 3x squared minus 26x plus 48 is equal to 0. So if we bring the 30x over the other side, it becomes minus 30x, and minus 30x plus 4x is minus 26x. And if we bring the minus 48 over the equal sign, it becomes plus 48. So drawing out this graph, we have it here, and determining where this graph cuts the x-axis, we can determine the solutions of f of x equals to g of x. So we can see it crosses at 6 and it crosses at approximately 2.7. Hence, our estimate of the values of x is 2.7 and 6. So another way that you can find where the two graphs would intersect, or in this case where the two trains would be level with each other, is by letting them equal to each other, drawing out the graph that they form when they're equal to each other, and finding where it cuts the x-axis.